We are going to have a look at tangent. I was calculus. We're going to have a look at the tangent. The tangent to the curve. Let's draw this curve here. And that Cartesian plane curve. Yeah. The curve passes down and down. You have a tangent to it. A tangent to the curve. Tangent to the curve. Tangent should of course be a tangent. A tangent will touch the curve at only one point. A tangent touches the curve at a point. Now this f of x is the basic quadratic there. What do you have there? Now, a tangent is of course a line. I'm not talking about the trig ratio here. Talk about the line, and a line is represented by the standard form. By this equation, the standard form y is mx plus c, and that is the slope, and then that will be the y-intercept. So for you to be in the position to can give the equation of a line, you need to have A, the gradient or the slope, and you have B, the y-intercept. Then you can give the equation of that line. Now, we talk about the slope. The gradient. This is what we talk about in elementary mathematics. In advanced mathematics, which is of course calculus, this is elementary. Elementary maths. In advanced mathematics called calculus, we talk of the derivative. Now let's see what happens. So basically, when you talk about the slope, talk about the derivative. Now, if I differentiate, if I want the derivative of that function is going to be 2x. Now, they say you're also given that you give the tangent touches the curve at x equal to 3. Note the tangent touches the function at x is equal to 3. Now, it is of interest to know if x is 3, what will be the value of y? If x is 3, then what will be the value of y? So we can say f of 3 will be 3 squared from our function up there, and that will give us a 9. Now that coordinate there, this coordinate where function meets, it can be written as 3 and a 9. Now, you have that. Now, the derivative, the value of the derivative at x is equal to 3 will be 2 by 3, and that will give us a 6. Now, be careful. This implies that 6 is equal to the derivative. That is to say, m is equal to 6, or 6 is equal to m up there, because that's the slope. Now, you can give your equation with something that you know now. You know one thing, that m is 6. But now, you don't know the value of the y-intercept, which is c there. So what you will do, you have y here, you have x, but you have the one coordinate, which is 3 and 9. Now, the coordinate 3 and 9 is on the parabola in as much as it is on the straight line, which means 3 and 9 as a coordinate satisfies those two equations or those two functions simultaneously at this point here, at x equal to 3. So, this being the coordinate, this is x, and that is y. Substituting here for y, you will have 9, 6, x is a 3, plus c. Now you have one unknown. Now you can see that your c will equal to c will equal to 9 minus 18. 6 by 3 is 18. And that will be minus 9 is equal to your c. Therefore, now you have the y-intercept, you long got the slope, you can give the required equation of a tangent required equation of the tangent to the curve x squared at x is equal to 3s y 16 of x minus 9. Now, there are a number of things which makes us happy here. One is that the y-intercept is going to be negative. In any way, we got -9. You should be happy somewhere. And that gives you the equation of the tangent to the curve f of x at x equal to 3. Now let's look at the other one. The other one says, given f of x equal to 2x squared minus 6x, given f of x given f of x is equal to 2x squared minus 6x. Says calculate the average gradient. 1. Calculate 1. The average gradient. Between the points with x is equal to 2 and x is equal to 5. Number 2, the gradient of the tangent to the curve where x equal to 3. The gradient of the curve the gradient of the tangent, not of the curve, gradient of the tangent to the curve at x is equal to 3. Now, we are going to calculate for the slope, and the slope is given by y2 minus y1 into x2 minus x1, and that will be the slope is a gradient is given y2 minus y1 into x2 minus x1. Now we need to know the value of y when x is a 2. Therefore, we say f of 2 in pursuit of this, which you don't know. X is 3 and X is 2 and X is 5 here. Life is easy. F of 2 will be 2 squared minus 6 and 2. And that will be 4 times 2 is 8 minus 12, which is minus 4. So basically, the coordinates here will be 2 and minus 4. The first one being x, the second one being y. And then f of 5 will be 2. Wherever I see x, I put in my 5 squared minus 6, 5. That is 2 by 25 minus 30. This is 50 minus 30. That gives us 20. So the coordinates here, 5 and 20. Using the basic thing there, we say y2 is 20 minus y1, which is this one here. Don't forget the first negative sign is that which comes with the equation. And then this one here is because of the minus 4 there. And then here we'll have 5 minus a 2. Negative times negative is a positive. We add 24 divided by 3. The answer will be 8. That is your gradient is 8. But the tangent to the curve, the gradient of the tangent to the curve, the gradient of the tangent is given by the derivative. And then we know that f of x, we are given that f of x, we're given that f of x is equal to 2x squared minus 6x. So if I differentiate that, the derivative, which is of course the gradient, will be 4x minus 6. Now, so the gradient at at 6 will be at 6 will be 4, 6 minus 6. But basically, we have that being the gradient. But you are given, let's have a look, let's compare. Oh, F3, not F6. F3 will be F3 will be we have to erase the 6 there and put in the 3 at x is equal to 3. Put in the 3 there, it's going to be 3 times 4, which is 12. 12 minus 12 minus 6. The answer will be 6. Put the 3 there. This is 12 minus 6. The answer will be 6. So that's what you have. I hope you got that. This is how you use the gradient to find the equation. And that's enough. We meet next time.